Let's bring them up on stage, everyone. Let's give them a hard time.
Get my presentation and it looks like I'm the right person with my presentation. So yeah, welcome again. Oh, there are many of you, it's great. So, what you should know about me. I work in cancer research, it's been already said. So you might kind of wonder like what I look like in my everyday life, right? So you might think I might be like a biochemist, a biologist, working in a lab like this, pipetting from left to right every day. Or you might think, oh, maybe he could be in clinics, right? Like a medical doctor, a medical professional working with patients. There are many ongoing trials related to oncology and cancer in clinics. Or you might say, well, actually, we know that nowadays oncology is heavily dependent on high-tech things, right? So you get a lot of these super sophisticated machines. You actually need engineers, right? You need engineers to operate the CT scans, PET scans, and magnetic resonance and such. And indeed, all these people are very important in research, clinical research, basic research, and also when really helping the patients. But actually, my working environment is quite different, and it looks like this. Right? So it's, doesn't look so fancy, just many screens with many lines or codes. And rather than looking like any of these figures behind me, honestly, I must admit I'm better something like this. And that's actually the topic of the talk today, because I want to show you or give you an example how even people like Sheldon Cooper can be quite important in this cancer fight. And indeed, the topic is that I want to show you that you can actually use math to fight cancer. To actually explain to you or give you an example, we need to go really, really deep into every single cell of your bodies. If you go really deep, you get to the nucleus, and you will basically find this molecule, right? This is the DNA. This is the long biomolecule, which carries all the genetic information. And how to think about it? I think about it as a huge cookery book, right? Because it's all the possible information for every single cell in your body. What to do are encoded in this huge cookery book. Like, think that you put together all the recipes from all over the world and put them in one huge cookery book. That's the DNA. And the individual recipes, the individual instructions, are the genes, right? And then in the healthy cells, which genes are active, turned on or turned off? This is heavily regulated based on the functionality of the cells. Makes sense, right? Because all the cells in your body have the same cookery book, but you have different cells, right? Obviously, you have cells that form your muscles, cells that form your brain, cells that form, I don't know. And they have different functions, so they activate different genes. It's the same thing like going back to this cookery book example, like if you go to an Asian restaurant, you expect Asian food. If you go to an Italian restaurant, you expect pizza or something similar. But, unlikely, there tend to be like a very egocentric cells as well. And these egocentric cells don't want to play by the rules. Well, why should we, right? They say, well, we can actually, activate different genes. Who are you to tell us? These are the cancer cells. These are the bad guys. This is not good for the system. And, it's the same thing, right? So suppose you come to an Asian restaurant and they serve you pizza, right? So it's a signal something is going wrong, and you might be pretty sure that the pizza will not be of high quality. But so we want to remove these cells from the game, right? So if you come to a restaurant where it's an Asian and they serve you pizza, you want to close it, right? No more pizza from this place. And actually, this is also the way how you can trace the bad cells, because you can identify the differences in their gene activation as compared to the healthy ones. And biologists know how to do it, and they can collect the information. And by this means, you can identify the bad cells and then attack them and remove them from the organism. Possible. But it's not so simple. First, the problem is that the gene on-off, it was a little bit oversimplified, so it's always a little bit something in between. So to decide when it was really on or off is a little bit complicated. Second, you have thousands of genes, right? So the problem actually multiplies by thousands of genes that you need to investigate. Plus you have thousands of cells, you can look into thousands of cells, right? And what it all results to? Yeah. something like it's like a huge data set, right? That you just look into the files like this, and that's how you might end. Right? So now you can imagine the scientist, the biologist actually working towards this goal, looking into the data, but there's a big risk that they will be flooded by the big data and that you will drown. And that's actually when we come to the game. That's our key. Because at the moment where all hope is lost, you hope there's no one to help you. Yeah, that's how we see us. We're coming right in time to help the poor people, the poor ones, drowning in the data. Bioinformatics is true. Yeah. And we're not coming bare-handed actually, because every true saver is equipped with the proper material. And we have our life-saving tool as well, like David Hasselhoff used to have 20 years ago when saving people from water. Because we know how to answer the questions that the biologists have in a proper way by actually applying mathematical statistics. And that's our goal. So the biologists make crazily complex experiments, very sophisticated. They generate big data, and they need somebody to help them interpret that in the proper way. And that's what we're here for. And that's also the message I want to tell you. That nowadays, in current cancer research, people generate huge data sets that need to be analyzed in a proper way to help the biologists, and not only the biologists, interpret what their experiment is telling them so they can continue with their research. So the message to learn from today, that apart from these people, which are still the main important backbone of the research, you also need, perfect body shape. Yeah, but actually, to be a little more precise, I should do it like this, right? So with that, I want to thank you for attention, and hope you'll have fun in the evening that's coming next. Thank you.